Okay, you know the scene. You've done it a million times. You grab a spoonful of salt, dump it in some water, give it a stir, and poof, it's just gone. It honestly feels like a little bit of kitchen magic, right? But what's really going on is this incredible microscopic drama of attack and escape. So, let's pull back the curtain and solve this everyday mystery together.
Yeah, it's a super simple question, but it leads to some really fascinating science. Seriously, where did the salt go? I mean, it didn't just blink out of existence. And trust me, by the end of this, you're going to know exactly what's happening inside that glass.
All right, to get this story, we first have to meet our main character. Or maybe in this case, our victim, the salt crystal. You see, before it even gets near water, salt is this amazingly organized and really stable structure.
Yeah, see, salt isn't just some loose powder. If you could zoom all the way in to the molecular level, you'd see it's a crystal lattice, a perfect repeating 3D grid. I want you to think of it like a microscopic fortress, built with positive sodium ions and negative chloride ions, all locked rigidly in place.
And believe me, this fortress has some serious defenses. Because salt is an ionic compound, its positive and negative bits are held together by these incredibly powerful electrostatic forces. We call them ionic bonds, and these things are strong. It takes a whole lot of energy to even think about breaking them apart.
So if the salt crystal is our victim locked in its fortress, well, then it's time to introduce the culprit, the agent that's totally responsible for this whole disappearing act, the water molecule. Now, on the surface, it seems pretty innocent, right? But water has a hidden superpower.
And that superpower comes from the fact that water is what scientists call a polar molecule. And this is the key to everything. It just means that the electrical charge inside the molecule isn't spread out evenly. One side's a little bit negative and the other side's a little bit positive.
So here's how that polarity thing works. The oxygen atom, it's electron greedy. It pulls the electrons it shares with hydrogen a little closer to its side. This gives the oxygen end a slight negative charge, which leaves the hydrogen end with a slight positive charge. And that's why every single water molecule acts like a tiny two-sided magnet.
So what happens when you drop that salt fortress into a whole sea of these tiny little water magnets? Well, the action begins. And it's not some gentle mixing, no, it's a full-on molecular tug-of-war.
The fancy scientific name for this epic battle is the ion-dipole interaction. It's basically the magnetic attraction between the charged ions of the salt, the sodium and the chloride, and the polar dipoles of all those water molecules.
And here's the play-by-play. First, millions of these tiny water magnets just swarm the crystal, and the attack comes from two sides. The water's negative oxygen end latches onto the salt's positive sodium ions. At the same time, the water's positive hydrogen end grabs onto the negative chloride ions. Now, one water molecule is way too weak to do anything, but the combined pull of thousands of them, it's just overwhelming. They literally conquer the crystal's defenses and just rip the ions right out, one by one.
So, the crystal has been completely dismantled. The fortress has totally fallen. But this brings us right back to our original question. Where did the salt go? Okay, this is the reveal. And the answer is, it's just hiding in plain sight.
You see, once an ion gets pulled free, it gets completely mobbed by water molecules. This process is called hydration. They form what's called a hydration shell all around it, with all the water molecules pointing their oppositely charged ends inward. This little shell acts like a cage, effectively trapping the ion and making sure it can't find its way back to the crystal fortress.
So there it is, the solution to the whole mystery. The salt never disappeared at all. It was just disassembled. It went from being one big visible crystal to trillions of individual ions, each one perfectly camouflaged by its own little shell of water. They're all still there, just way, way too small for us to see.
And the final result of all this molecular drama is what we call an aqueous solution. It's a perfectly uniform or homogeneous mixture. All those little hydrated ions are spread out evenly all through the water, which is exactly why the water looks completely clear, almost like nothing's in it at all.
Now, for any of this to work, a little energy battle has to be won. Think of it like this. The lattice energy is the strength of the salt fortress's walls, and the hydration energy is the power of the attacking army of water molecules. For the salt to dissolve, the hydration energy just has to be stronger than the lattice energy. And in this fight, the water army wins, hands down.
And there's one more thing that's pushing all this along. Like the slide says, nature kind of loves a mess. Scientists have a word for this. It's entropy, the natural tendency towards disorder. And think about it. Going from a perfectly organized crystal to a chaotic jumble of ions floating around everywhere,
That's a huge increase in messiness, which nature actually prefers. It's like an extra little push that helps the dissolving happen.
Okay, so we've explained that the salt is still there. It's just broken down and hidden away. But how can we actually prove it? Is there a way we can make the salt stage a great return? Oh yeah, and it's actually incredibly simple.
The proof is easy. Just get rid of the water. If you let that salt water just sit out and evaporate, you're removing the culprit from the scene. As the water molecules escape into the air as vapor, they have to release the ions they were holding captive. And once they're freed from their little water cages, the sodium and chloride ions find each other again and snap right back together, rebuilding their crystal fortress right there in the dish.
So you see, disappearing salt isn't magic at all. It's this beautiful, invisible dance of electricity, energy, and, well, a little bit of chaos. And it really makes you wonder, doesn't it? What other everyday magic is just incredible science waiting for us to take a closer look?